Mark, it's so great to have you here. This is a heavy subject, but one that I know people are going to be interested in and appreciate your vision on this and your research and all the work that you've done. So we're going to be talking a lot, well, pretty much all about cancer today. And we all know somebody who's affected by cancer, whether or not we've lost somebody or somebody got a recent diagnosis, or it's just one of those things that people probably have on their mind a lot. Like, my mom died of liver cancer 2 years ago. And I think, yeah, is this it for me? Like, is that how I'm going to end up? So we'll answer a lot of those questions today. And your book is really profound. We'll definitely go into that a little bit, but your view on cancer is very fascinating and very interesting. And I really appreciate all of the work that you've done. So just start out, tell us a little bit about you and your backstory and why you got so interested in this topic and how it led you to write your book.
Yeah, thank you, Shana. It's very nice to be on your podcast. Really appreciate the conversation. And yeah, it's unfortunately a subject that touches everyone's heart, really. Not everyone is directly affected, but indirectly normally. So it's really important to discuss these issues. For me, it was a personal diagnosis. So my background is actually in graphic design, and I was diagnosed when I was 28. I thought I was healthy, and that led me into the first part of my research, at the first stage, really. And I wanted to understand which DNA genes cause my particular cancer because I wanted to prevent it in future. And my oncologist, my GP, couldn't tell me. So I thought, I'd just go and check online. I know you've got to be careful online, haven't you? Because there's a lot of potential misinformation out there. Um, so I delved into the medical literature and excuse me, it became apparent that it was a lot more complicated than was being presented because I thought that cancer, or I was given the impression that cancer was a genetic disease, and that was almost fact. That's what we're kind of like told, and that's what the medical textbooks say. And if you're a medical student, that's what you go through your medical education being told effectively. And it just became apparent quite quickly to me that you know there wasn't a specific set of DNA mutations. There wasn't a clear-cut pattern that could explain cancer in many different types of cancer, and that confused me somewhat. And then I came across research that showed that the mutations were random, and then shortly after, I stumbled across a number of other cancer theories that I didn't even know existed, and that was really the spark for me for my curiosity. Um, and you start listening, you start going down different rabbit holes of different theories, and there's quite a number of theories out there. I'd say that there's at least seven credible theories. I mean, you're talking that there's upward of 25, 30, really, if you really want to go into it. But there's at least seven credible theories that are worth considering. And yeah, I came to understand, hear about these theories. I I had my cancer removed, so it wasn't shortly after that I stopped doing the research and I carried on living my life. But then a close friend of mine, Sam, she developed cervical cancer, and knowing what I'd already found out, I thought, you know what, there's not much I can do to help her other than be there for her. But everyone's doing that. What else can I do? I've done this research already. I'll dive back in because I already knew there were probably metabolic adjuncts you could do, such as fasting, that can improve your recovery from chemotherapy, for instance. So I knew this already, and I thought I'll go down this route. And I already heard the voices of a lot of alternative practitioners saying, "Oh, you can take all these compounds and all these natural supplements, and they can help." And I wanted to flesh out the good supplements or the good information from the bad effectively to see if I can help her on this journey. She went with standard of care in the end, and she passed away after a year. But that year led me down quite a number of rabbit holes, and I went quite deep in the research, and I learned quite a lot. So I wanted to document that. I wanted to document it because um, it would highlight to people that there were these other options to consider. And hope the idea being, if any family member of mine or friend got cancer, I could literally give you this document with research links, so that they could pursue it themselves and really get to realize that there are other perspectives that need to be considered, not just the singular perspective we're provided with. So that's how it all started. But as I went through that process, it became more of an obsession. Sam's death kind of it motivated me. I didn't want her death to be in vain. I was quite angry at the time, and I just wanted to know more for myself and for family and friends. And that later transpired into 8 years of research. I didn't expect it to take anywhere near that long, but along the way, I taught myself all the main details of the main theories. I went on an objective look into all aspects of health and disease to see if I could see some sort of pattern. And I had this notion in my mind that scientists had already created enough evidence out there for us to maybe shed more light on the underlying mechanism behind the disease. And all that was potentially needed was for someone like me to just objectively look at the evidence and see if there was any patterns that had been overlooked. Because when you start to look into these different theories, aspects of human biology are incredibly complex, and you see that sometimes scientists can get lost within a particular paradigm, and a lot of the different disciplines within health, they don't necessarily talk to each other very well. They stay within their silos essentially, and I saw that as a problem because they're not conversing with each other, and as an opportunity to, see if I could see if there was a pattern. And lo and behold, I around 4 years in, I started seeing this particular pattern, and I came across some research which suggested that there was a different mechanism behind the Warburg effect in cancer. And that was really key for me. And from there, I then developed what I now call the cell suppression theory. It offers a completely different paradigm for viewing the mechanisms of cancer, and offers a completely new mechanism that potentially could be driving the disease. So that's exciting because it offers additional treatment options, but it's not just for cancer. It ties in with metabolic health. It ties in with health in general, and just basically identifies a potentially overlooked mechanism that we aren't really focusing on, but should be.
Yeah. Well, I certainly appreciate you doing all of that research and putting it all together in a book. And if it took you 8 years and that's, what you're primarily doing, it's so frustrating when you get that diagnosis of whatever type of cancer it is and the race is on. It's like, oh gosh, I have cancer. What am I going to do? What treatments am I going to pursue? And so you're in the UK, we're in the States. I know for us here in the United States, when you go to an oncologist, you get a cancer diagnosis, you're basically giving two therapy options. You're giving chemotherapy, you're giving radiation, I should say three, or you're giving a surgical option. And that is it. And, with my mom, it was so incredibly frustrating because I didn't know as much as I know now. This was a couple of years ago, but I remember going to appointments with her and talking about what you were talking about. I'm like, she'll be fasting around because she chose chemotherapy, even though I was like, oh, because she had liver and pancreatic cancer. I'm like, oh, like chemo with those are is it just like I didn't want her to, but that's what she was doing. So I'm like, well, we're gonna do some fasting therapies around it. We're gonna, eat ketogenically. And the oncologist just looked point blank at me and said, she cannot fast. She's a cancer patient. She needs to eat as often and as much as she possibly can because she's going, the chemo is going to cause her to lose weight and blah, blah, blah. And then they gave her a bag of Ensure packed with sugar and seed oils. And it's such a frustrating path when you get the diagnosis. So there's a ton to unpack here. But let's start with the Warburg effect because you mentioned that. And I'm sure there's a lot of listeners who aren't familiar with that. And that, you've done the research. If I'm not mistaken, that is something that all cancer cells have or cancers have in common, or there's some that don't. And let's start with the Warburg effect. What is that? And why is that important to know about when it comes to cancer?
Sure. It's a great place to start. And it's kind of at the crux of really my research. So the key point for me, going back to what you were saying there, firstly, is that it's so overwhelming when you look at the evidence online and the information coming out and the advice from different corners, that's why I created the book, is to effectively explain to in a patient-friendly way the current state of the industry and hopefully clarify what options are available for patients and clarify what theories are out there. And the other thing I'd just like to draw on before I do answer your question is that um, people may think as well, it's already overwhelming. Mark's talking about a cancer theory. Oh, this is just too overwhelming. Um, Um, but I've put forward a framework which highlights the importance of understanding cancer theory, and it can be understood quite simply, actually. And it's one thing I do in the book is explain the theories quite simply. But the reason why I emphasize theory is so important is because treatments are developed from cancer theory. And this is one of the things that isn't really mentioned or explained to the patients. There are many different cancer theories available. The accuracy of the cancer theories differ quite considerably. Now, that's quite significant because no particular theory at the moment has been proven to be correct, even though the genetic theory, the genetic mutations are the cause of cancer, that is presented as almost factual. It's not been proven. And from this perspective, what I've developed is like a framework which suggests that, hold on a minute, if you want to make a decision on which treatment to go for, we just need to look at cancer theory because treatments are developed from cancer theory. And then what you would do is you have a look at a number of different theories and you say, well, which ones are the most accurate? Because you want to really be siding with the most accurate theories that are currently available because the more accurate the theory, the more likely that theory is targeting a key mechanism. Because the more that theory can explain about the disease, it's effectively more likely to be correct on that particular mechanism it's talking about. And then you've got treatments associated with that particular theory, they're more likely to be effective. So I provide that information in the book, and there is a way of identifying which theories are more accurate than others, and that's the 10 hallmarks. We can talk about that later. And the difference is that my theory is one of the first to explain all these 10 hallmarks. All cancer theories are trying to explain them. It's the metric that you use for accuracy of each particular theory. But the metabolic theory is also very high as well, so it can explain at least seven. Proponents of the metabolic theory will say 10. So it when you look at it from that perspective, it really puts um, like kind of chronological order of which theories are more important to focus on, and then what treatments you can take from that, treatment incentives you can take from that, and that can advise you on roughly what you should be looking for, alongside standard of care, of course. So the metabolic theory is where it's really at, and this is where it comes into explaining the Warburg effect. Back to your question. Sorry for the tangent there.
No, that's important.
But if you'd like, I could share a couple of slides on the screen.
Sure.
Okay, just bear with me a second. Okay, can you see that at the moment?
Yes.
Okay, so very simply, I'll explain the energy mechanism at the moment because the Warburg effect is all about the energy system of the cell. So as we have here, a healthy cell, we have effectively two energy systems in the cell. There are more, but just to keep it really simple. And the first is what we call oxphos, and it contains the mitochondria just here. Um, and this is where you have glucose come into the cell, and effectively oxygen is combined with the glucose within mitochondria. These are like little bacteria, and they produce around 36 ATP units of energy. And it's that ATP energy that is then used um, for cellular functions around the body. So this is like a battery essentially of electricity, and it allows cells to share this energy and then use it whenever they need to. Then we have what I consider the backup energy system called glycolysis, and this is where glucose comes in but is fermented, um, and that releases much less energy to ATP units of energy, and also produces lactic acid. So this is like a great backup system because in life you'll have several situations where you might be sprinting and you need more energy, and you can only absorb so much oxygen. So the mitochondria can only produce so much energy. So they'll need this backup, and glycolysis provides that backup. It allows you to sprint suddenly because it can ferment glucose very quickly to produce energy. It just requires a lot more glucose because it doesn't need oxygen. Also, you'll have points in life where you'll have damage to your tissue, and that means the blood flow isn't going to cells, which means that oxygen cannot enter into the mitochondria for the mitochondria to make energy. So that's where glycolysis, the backup system, comes in. It sustains the cell while blood vessels are being regrown in order to provide the oxygen. So you've got an oxygen-based system and a fermentation-based system, and they work together. Um, Now, a cancer cell and the Warburg effect specifically is when oxygen is still present and available, so there isn't necessarily injury to the vascular system, but the mitochondria, for whatever reason, aren't producing energy. The cancer cell chooses to use glycolysis in this fermentation process instead. Now, this is a key feature of pretty much all cancers. There are one or two slight exceptions, like prostate cancer, for instance. Um, that isn't triggered by the Warburg effect initially. And so that's a key contention. And I do explain that. But generally, nearly all cancers utilize the Warburg effect. And sorry, with prostate cancer, it does utilize the Warburg effect later on, but not initially. But most cancers initially they have this switch in energy system to glycolysis when there's oxygen present, and that is called the Warburg effect. And it's called the Warburg effect because a chap in the 1920s called Otto Warburg discovered that cancer cells use this backup energy system even when oxygen is present. And that suggested to him that the mitochondria must be damaged because the oxygen is there. And when the oxygen is there, mitochondria should be generating energy, but for whatever reason, they're not. And the assertion is that it's because the cell is damaged. So that's effectively what the Warburg effect is, and why that's linked to cancer, because the Warburg effect is present in nearly all cancers.
And it's not new. This is not like this was just discovered 2 years ago. This
No.
we've known this for decades. And so this kind of leads us into like what are the 10 hallmarks of cancer? And you said there's like 7 credible theories out there. And so if you won't mind going through the 7 hallmarks of cancer and then looking at the theories, which one makes the most sense. And you've kind of put it all together into your book, The Cancer Resolution. Like, why doesn't everyone know about this? And why are we still, I think it's pretty obvious, but why are we still so honed in on that genetic mutation theory if it's not even proven?
Yeah, that's a very good question. Well, to start with, the hallmarks, there's in 2001 there was a paper by Hanahan and Weinberg, and they were looking to identify consistencies with cancer because with the mutations they were finding, there's many random mutations. And it was really difficult to kind of like pin down the patterns that were thought to drive cancer, or um, we would expect to be driving cancer. And so they identified 6 initially. And then they updated it in 2011 to 10. And then very recently, it's been updated to around, well, it's been proposed another four. So there's 14 really in total, but it's the 10 core hallmarks that are really accepted, widely accepted. And it's one of the most published or cited papers in cancer biology. So these 10 hallmarks represent the traits, consistent traits that every solid tumor expresses. You can't really identify a neoplasm as a tumor unless it effectively contains these 10 hallmarks. And the first one is uncontrolled growth, and then you have growth signal failure, cell death failure. So when the cell should die, programmed cell death, it doesn't. It's defying those signals. It doesn't want to die. Then you have limitless growth. It can grow forever. You have blood vessel growth. So it's now growing its own blood vessels in order to gain more nutrients. So then you have faulty energy system, the immune evasion as well, DNA damage, inflammation. So there's a number of basically 10 of these hallmarks, and the ability of cancer to spread as well. So that's where these theories are coming in. They're trying to explain all these particular aspects of the disease. And to speak to your last part of the question, it was around the 1950s that scientists really discovered the the structure of DNA. And because DNA is seen as almost like the God particle, it's the way we can maybe manipulate the activity of our cells to improve all sorts of diseases. So the assumption has largely been that a lot of disease is caused by DNA mutations because DNA is the blueprint for the cell, how the cell operates. So if we can learn this, how to effectively change the cell, we can do all sorts of really good things with DNA. But it's so complex. So this kicked off early in the early 1950s, 1960s. Massive amounts of funding came into this field of genetics. In the 1990s, the Human Genome Project was set up, and that was to identify pretty much all the genes we could identify in a cell, of which there's roughly around 21,000. And it took them 15 years to do that. This is how massive it is of a project. So you have this real huge juggernaut, effectively, of incredible number of scientists working incredibly hard on this incredibly complex aspect of understanding cell biology, and that's really pushed forward this focus, if you will, on the genetic side of things. And then as time went by, scientists have seen a number of mutations, and then the somatic mutation theory is what it's called, grew from there. And it's almost become a given when you go into medical school that this is the route we need to take. Cancer must be, it's asserted or assumed, cancer must be a disease of these mutations. These mutations can cause the cell to grow, that particular mechanism, the growth mechanism, to stick on or stay on. So therefore, that must be the underlying mechanism that drives cell growth. And then we have the P53 gene, which can regulate cell death. And if that's mutated, then that suggests that the cell death mechanism isn't working. So that explains two of the hallmarks, you could say. So yes, it's developed from that desire to want to understand this extremely complex aspect of cell biology. But what's happened is, over a period of time, coming into really the 2010, 2013, technology improved so much that we could then start to identify or catalog the mutations present within many different tumors over a very short period of time. It wasn't going to take 15 years anymore. It was going to take about a year. And that was really the first time we started to really see patterns, or not so much. We were expecting to see particular patterns with each cancer type. But what we found confused everyone, and threw the genetic model into contention, because a lot of the cancers were showing random mutations that were really unrelated, even within the same tumor, cells within the same tumor having random mutations from one cell to the next. But then there's a number of cancers that that didn't have mutations, driver mutations at all, yet those cancers arose. So that then begs the question, what's driving those particular cancers? And there's if you've interviewed Professor Seyfried from the metabolic theory side of things, he'll highlight that you had these nucleus DNA transfer experiments where they took the nucleus of cancer cells and transplanted them into healthy cells. And if the nucleus is causing the disease, i.e., the mutations in the nucleus are causing the disease, then you should see cancer effectively proliferation growing in these healthy cells. But that didn't occur. So there's a lot of evidence now that there's more data, which now places that theory in contention. But until this point, very recently, until this point, you had a huge juggernaut of scientists and investment moving into the field to try and understand how these how DNA interacts with cells and trying to understand it better. And that now is going to be quite hard to kind of move away from, because that's where the investment is still plowing into. And a lot of, like say, medical students are taught that that is the case. And when you make that your life, your career is earning money from this side of things, and you genuinely believe that genetic mutations are the underlying cause, it's going to be difficult to get certain scientists to see the flaws or the contentions in the theory and to start looking elsewhere, because there's less investment elsewhere, unfortunately.
Yeah, a lot of it is just coming down to the education and who's funding the education. And I saw that in my field too, with dietetics and going through the conventional system and, learning things that weren't actually helpful nutrition wise, and coming out of that practice because I realized, that wasn't the actual best way to nourish people. So yes, it's so complex and so frustrating. And then another point, I've kind of gone, you've had friends, and I've had my mom, I've had others close to me. It's like they start these therapies, and I know, like, after the first round of chemotherapy, my mom had all great intentions, like her mental mindset was there, and she just got so sick so fast. The brain fog, that she's just giving up basically after the first round of chemo, and it's like she wanted to research, she was a registered nurse, but just too sick. So, she just kind of continued on with what she was told to do. And 6 months later, 6 months was all she lived after her diagnosis. But so I want to go into, kind of what's outlined in your book, and go back to the treatments coming from the theories. And that makes sense. We have all of these theories and none are proven, which is, I find, very interesting. But I know in your book, you talk about how to base a treatment plan on what's driving the individual cancer. And I think that's the $1 million question. It's like, if we could figure out, well, what caused this cancer in the first place, what's driving it, then we can put a plan in place rather than just, this is what you're doing. We're going to knock out all your healthy cells. We're going to, so talk about that a little bit, because I mean, I think that's what everybody's wondering. Like, well, how did I get this cancer in the first place? How did it develop? Which is different from person to person. And there's so many things that go into that. But talk about how somebody, like, if they get a cancer diagnosis, and this is outlined in your book, but maybe you can kind of just give us some bullet points. Like, if they are given a diagnosis, how do they figure out what is driving their particular cancer so they can then find the therapies that can be helpful for them?
Yeah. Okay. Well, for me, it's definitely looking at the theories first. You need to be to sit down and try and find out what the metabolic profile initially is of your particular cancer. But first and foremost, for identifying the correct treatment or the most effective treatment comes down to, really, for me, um, finding out what the underlying mechanism is that's driving it. Because at the moment, we have a number of these theories, and effectively, when we're searching the internet for particular compounds that might improve our situation, or we've heard of someone else who's used this product or this drug and it's worked for them, we're kind of still shooting in the dark, and it's guesswork, and we don't really want that. We really want a robust backstory, if you will, that gives us confidence in choosing those that particular treatments, rather than just guessing, because we have limited time when we have a diagnosis. So at the moment, there isn't a one size fits all, unfortunately, but there is a foundational basis based on the theories that are being presented. So for me, it's looking at the theories and which ones are the most important. And I will say, from what I found, is the metabolic theory is the primary established theory. Then you have the cancer stem cell theory. So that means you need to be targeting cancer stem cells. That's really important. Um, there are different ways to do that. And the tissue organization field theory, and that's where they're suggesting that the damage to the tissue, the inflammation, is the major part of the problem, because it prevents the signals getting to the tumor to tell it to stop growing effectively. So it's to look at the terrain, it's to reduce the inflammation as much as you can, it's to fuel the immune system, and support holistically your body's healing abilities. Now, there is a caveat there in a sense, because I haven't explained my theory yet, and the reason why. And that is that you have these other theories. And the reason why I did develop my theory is because these are the theories, kind of like, they all point to the same thing. They all, I think, make a fundamental error in judgment. And that is they all initially start on the premise that cancer is a disease of cell malfunction. And that is, a damage to the part of the cell happens, and then that causes the cell to develop autonomy, and it grows out of control. It wants to be alive and not listen to all the other mechanisms that are going on, telling it to kill itself. So damage to the cell. The cell has malfunctioned. Now that's the DNA. That's DNA. The somatic mutation theory says the DNA is damaged. That causes cancer. The metabolic theory says the energy system that we described with the Warburg effect, just that damage, that is damaged, and that malfunction then causes cancer to arise. Now, the issue I have with that is all those theories that are saying the cancer cell is a result of malfunction, kind of like point to the cell being an enemy and something you need to attack. And normally that's with toxic compounds. We need to eliminate the cells in the tumor. And this is why we have toxic chemotherapies that are effectively working against the body's natural healing abilities to initiate a cytotoxic event. And the hope is to damage the tumor before you do too much damage to the rest of the body, and the rest of the body then repairs itself. So all these other theories effectively do indicate that we should be targeting and attacking our cells. The exception with the metabolic theory is that they do offer the narrative of fasting and a ketogenic diet and restricting glucose and initiating the natural catabolic healthy response, where your body breaks down certain tissues, breaks down cells, and becomes more efficient in its operating. So that does support the body holistically. But the difference with my theory is that I'm not saying actually cancer or those cancerous cells are our enemy. I'm saying there are our cells. They're doing the best they can in the situation they're currently in. So just to very quickly explain, the Warburg effect that we just referred to earlier, that forms the basis of the metabolic theory. So all cancer cells shift over to this Warburg effect. I'm saying I found evidence to show that actually that Warburg effect can be explained in a different way. I'm saying that actually the mitochondria, whilst they're damaged, they're not dysfunctional. They are not, that malfunction is not causing this energy shift. So for me, it was all about, how do you explain this energy shift? Because this explains a consistency of the disease, and that's the important thing. If you're trying to, work out complexity such as this. And I came across evidence that highlighted that infection, particular type of infection, triggers the Warburg effect. In fact, in immunology, they use that phrase, the Warburg effect. So this is where, say, a fungal pathogen invades a cell. what happens is the mitochondria intentionally, not because they're damaged, but they intentionally suppress the energy system that they use. So they suppress the oxygen pathway. So from a metabolic or a traditional standpoint, it looks like, oh, the mitochondria aren't using oxygen. They must be damaged. That's the assumption that's been made. And I'm saying, well, actually, there's another explanation. Uh, it could be that the mitochondria are intentionally suppressing themselves in order to attack the pathogen. And what they're doing is, or what seems to be doing, I'm proposing this, and a number of the models suggest that this is the case as well, such as Dr. Robert Navio's cell danger response model. That is that upon identifying the pathogen invading the cell, the mitochondria, which are also a defense mechanism of the cell, by the way, they use the oxygen to attack the pathogen by generating reactive oxygen species. This is a defensive mechanism that immune cells use. So what you effectively have is an invasion of fungi, and I'm proposing fungi, but it could be bacteria and parasites as well. That's the premise behind the cell suppression aspect of my theory. So OXPHOS in mitochondria, the energy pathway is being suppressed on purpose because the mitochondria are rewiring their process in order to use the oxygen instead of making energy to combat the pathogen. That forces this shift over to glycolysis, we see. So glycolysis supports the mitochondria in their attempts to defend the cell against the pathogen. It provides the ATP energy. And what I'm saying is what actually happens is in damaged tissue that's been damaged chronically for a long time, you have a weakening of the mitochondria's ability to defend the cell. You have a weakening of the immune system because they're dealing with many toxins. And you have this opportunistic moment where these pathogens that are present within the tissue, they sense the tissue is damaged. In fact, they use lactic acid. They sense the level of lactic acid in the tissue, which is a sign of inflammation. And when it reaches a certain threshold, if these pathogens are present, they then use that to effectively change into stealth mode. So they hide themselves from the immune system and then they invade the cell. And they can feed off the lactic acid as well. So when they get into the cell, if they manage to establish themselves, what effectively they've done is they've hijacked the cell. They've forced the cell to stay within this mechanism of using the backup energy system because it's an anti-infection response. So the cell gets stuck producing energy via this backup energy system, the Warburg effect. And that's because the pathogen is present. If you eliminate the pathogen, then you eliminate the need for the cell to stay within this Warburg-like energy state, and then the cell goes through the cell repair phases and reverts back to normal, or it triggers cell death if the cell's damaged past a certain threshold. So it's about eliminating the pathogen. That's the premise behind my theory. The theory is that the energy system switch can be explained by this interaction with the pathogen. And on top of that, what we also see, and the reason why I've been able to explain all these 10 hallmarks, is that fungal pathogens can effectively do all those things. So they suppress the ability of the cell to kill itself, apoptosis, on purpose because they want to survive, because they're now getting access to the nutrients that are being absorbed into the cell. And the cell's protective against the immune system. Plus, you have a lot of information on how cancer cells can allegedly suppress the immune system to evade it. Well, what we find is during infection, the fungal pathogens upregulate the exact same pathways to hide from the immune system that we see in cancer. So they are modulating the immune system. They're shifting the immune system away from one where immune cells target pathogens and only focus on cell repair. And that benefits the pathogen because it's not being identified and attacked. So for cancer patients trying to understand where they should go with this, what I'm offering is that metabolic therapies are antifungal, are antimicrobial, and the Warburg effect is a key mechanism that is involved in all cancers. So the metabolic theory and my theory are interlinked, are tied, because it's very clear that that's a consistency of the disease. So taking it back to the beginning again, then anyone looking at my book or coming to understand these different theories, It starts with effectively the tissue organization field theory, which is look after the terrain of your body, reduce inflammation as best you can, help support the immune system. It's looking at cancer stem cells because they play a minor part, and we haven't had a chance to really talk about that today, but they're important because they deal with the unlimited growth aspect and the chemotherapy resistance aspect of things, but they need to be targeted as well. So that needs to be noted down. How do we target these particular things? And then it's the metabolic side of things because of this energy shift, the cell is now absorbing a higher rate of glucose. So that's a metabolic weakness. Because if you have a situation where you fast or you reduce the availability of the glucose, although the body can regulate glucose by the liver producing it, so the bloodstream is effectively has the same level of glucose in it most of the time, you can still reduce that level when you get into ketosis. And then you have a situation where cancer, in order for cancer cells to survive, they need a higher rate of glucose. But if that glucose isn't available because the rest of the tissue is competing with it and doesn't require that amount of glucose, then you have an ability to weaken the tumor because it can't access the amount of glucose that it needs to in order to facilitate its growth. The problem comes where someone is consuming far too much glucose, that the tumor can get easy access to a large amount of the glucose that it requires. Now, of course, that is the fuel of the fungal pathogen, most fungal pathogens. So you're feeding the pathogen as well. But if you restrict through metabolic therapies, what you're actually doing is you're restricting the fungal pathogen's ability to get access to its primary food source, and you're strengthening the immune system at the same time. What we see with people with infection who utilize a ketogenic diet, say, you're seeing the antimicrobial, the pathogen burden reduced. So it's an antifungal modality that wants to be included. So even if you don't subscribe to my theory, but you do the metabolic theory and you do metabolic treatments, what you are actually doing is also restricting the pathogen if it is actually a major part of causing the disease. So go with the metabolic therapies. And then on the top of that, look into the relationship with my theory and how they will fit together. And that is because I'm saying it's potentially the fungal pathogens driving most of the disease, you can add in potential other drugs and antifungal drugs or natural antifungal compounds to get them to work in synergy to target the pathogen. And what we see is itraconazole, for instance, which is toxic. I'm not saying that's what you should be using. It's an antifungal drug. It's toxic, so you've got to be careful. But we're seeing a broad spectrum efficacy against a great number of cancers with just itraconazole, and that's an antifungal drug. Now, the benefit of that is that, again, looking through this framework of trying to decide which treatments to use, of looking at the theories, itraconazole, the drug, targets the metabolic pathways. So you're not only targeting from a metabolic theory point of view, if you believe that to be correct, but you still think there might be something in my theory, you're also then targeting the fungal pathogen I'm saying is potentially driving the disease as well. So you're covering both angles. So why not go with drugs that do both? And then we find that there are a lot of off-label drugs. That's the big thing really now in the alternative space. And a lot of people utilizing these. And what I found through my research is, and I got a chapter that talks about this, is that I wanted to work out what's the commonality. Why these different drugs like metformin or lovastatin or ivermectin or mebendazole, why are these antiparasitics working? And you find out that they're all antifungal as well. They have an extra property that no one's really clocking or identifying. It's only really me at the moment because I'm looking through this lens of there is this fungal involvement. Is there a link here? Is there a link here? Is there a link to all these drugs? And yes, there is. What you find is I'm suggesting the pathways link all the way back to fungal pathogens. So these other drugs are actually antifungal. So I'm arguing the case: are the people who are having beneficial effects from using these alternatives, are they having beneficial effects because they're inadvertently targeting the pathogen that I'm saying is the issue? So it's not just so. Yeah, that was a lot to unpack, but there's even more. So I'll just quickly go through the rest of it. It's looking and addressing the microbiome because the microbiome is a major part of our defense mechanism, especially the gut. But also, if it's out of whack, then you're getting uh, exposure to mycotoxins, bacterial toxins, and the pathogens then can rise up effectively to generate the disease, as I'm explaining they do. So the microbiome is super important. It's it's not just looking at the metabolism in terms of restricting glucose. It's also improving your metabolic health. So exercise, maybe hyperbaric oxygen therapy. Because what we're effectively doing with my theory, I'm saying that our cells are working to actually help us. They're not the enemy. We shouldn't be killing our cells. We should be supporting them. So what we're going to think about is the mitochondria are trying to use oxygen to target and kill the pathogen. But over time, that the access to the oxygen is reduced, and the antioxidant defense mechanisms within mitochondria are reduced as well, which causes all sorts of damage, and that doesn't allow the mitochondria to focus on the primary feature of killing the pathogen because the immune system and everything else is trying to deal with the damage to the tissue now. So if you use certain antioxidants, they need to be sourced naturally and it needs to be carefully considered. So there's a chapter on that in the book as well. The antioxidants help the mitochondria prevent the excess damage they need to. But then if you use something like hyperbaric oxygen therapy or methylene blue or anything like this, anything that can support mitochondria to improve their ability to use oxygen, then what you're doing is you're supporting their ability to utilize that free radicals or reactive oxygen species to target the pathogen. So that that adds in another level of it efficacy in terms of fighting the pathogen or fighting the cancer cell. Plus, with physical fitness, you're increasing the number of mitochondria that are available within the cell to help fight the pathogen. You're increasing the blood supply, you're increasing the oxygen supply. So again, it's all beneficial, holistically supporting your body's natural defense mechanisms. And then there's obviously the mental health side of things. The happier you are, effectively, the less inflammation you have within the body, and the more your immune system becomes more effective. And we could go, if we have time, we can go into the mechanisms of that. And yeah, really, the final thing would be with my theory: consider all this, looking, but also do it from an antifungal perspective and metabolic perspective. So address the infection, look at the mycotoxins in the body. With the inflammation side of things, you might be getting mycotoxins in the food, and these mycotoxins damage the DNA, and they suppress the immune system. You might be exposed to fungi in the home, so it's not just the fungi in the body; it's the whole holistic side of things where you want to be reducing inflammation as much as you can, and you'll have mycotoxins being produced by the fungus itself because those mycotoxins suppress key mechanisms within the cell that enable them to survive. And then the final thing would be biofilms as well. You need to break down the biofilms because once fungi establish themselves, they're really difficult to get rid of. Even antifungal drugs don't enter into the biofilms, so the fungi that are present in those biofilms can survive. So you may be able to eliminate the tumor, but if the biofilm still exists surrounding the tumor or that tissue and fungi exist within, and you return to the damaging lifestyle that you previously had, then you have the chronic damage, inflammation in the body. You can have cancer can form again because the pathogen will just take the opportunistic moment to invade the cell once again. So it's breaking down the biofilms and being aware that that's a key need if you must. Sorry, there's
Yeah.
a lot to unpack there.
No, there's a lot to think about there, Mark.
Sorry.
No, it's fabulous information though, and just so much of it makes sense because there's definitely a couple holes in the metabolic theory. And I remember when I interviewed Dr. Seafried, we talked a lot about fasting and ketogenic diets and limiting the glucose involvement, but there was also glutamine to think about and pulsing that, and how a lot of people were able to either shrink or reduce their symptoms and their tumors, but not completely overcome them a lot of the time. And I know I had a lot of people like email or get in touch with me, like, what did Dr. Seafried mean about the glutamine? Like, it's in everything. I'm like, I know. And so I know that was a really confusing part of the treatment protocol that he was using, and it's just not established as standard of care in the States, that's for sure. So that was definitely a roadblock. But a couple of things. So now it makes sense why reducing glucose, why the fasting, why all of the down regulation of the healthy cells, especially if you're doing a chemo like that, makes sense. The hyperbaric oxygen, the methylene blue, like it all makes sense. A couple of questions I have. So your theory more so has to do with going after the pathogen that is causing the energy differentiation.
Mm.
Now the cells are using more of the lactic acid, and they're in the Warburg effect, and they're not using glucose metabolism like they normally do, just to kind of make sure I'm understanding everything correctly. And a lot of this is because there's a pathogen. So, and I know you said that the pathogens, we'll kind of end on this so it can just give people some idea of where to start. Like the pathogens can be different. Like you mentioned antifungal treatments, biofilms. Like I know what a biofilm is. Like my kid suffered from ulcerative colitis and like we just a lot of inflammatory bowel stuff. So I'm familiar with what biofilms are. It's basically like snot wrapped around the pathogen that protects it. And that can be very hard. Like even if you're given an antifungal or antibiotic, an antiviral, whatever, if they're wrapped in that like snotty, mucusy kind of protection, you can't get to the pathogen. Pathogens are really smart and they want to evade being killed because if their cell dies, they die. So they're really, they can be really hard to target. So one, is there any way, like I know you said, like to get some like test for mold and that sort of thing. Is there any way to know what kind of pathogen is is kind of driving this whole process? And because I mean, I'm sure there's all kinds of different testing and all of that, but or is it more just like let's just work on the immune system and the metabolic system? And then going along with those biofilms, like how do we go after the biofilm? Because like I know I did this research like 10 years ago, and what I researched back then was probably not the most, it's not the most recent data. And we'll just kind of wrap up because I think you gave us a lot of great points on how to prevent. And I want people to know, and maybe you disagree with me on this, but cancer doesn't just happen. Like it's not like, oh, I just got like cancer just started in my body one day. We all have cancer cells. But why do they mutate? Why do they grow? Like that's kind of the bigger question here. So definitely preventive health, and all of the things that you listed. But let's go back to like, is there a way to identify the pathogens that might be causing the cancer? And how do we go after those biofilms? And this is probably all outlined in your book, I would imagine. But I think people are probably wondering that, okay, well, if it is a pathogen, how do I know what to do about it?
Yeah, so this is the really the bone of contention. And firstly, I'd just like to highlight that I'm not a clinician, and none of the information I'm presenting is medical advice at all. It's just information for people to go away and research for themselves. Excuse me, I've got a very tickly throat. Um, and then go to your physician to ask their advice. Obviously, always seek medical advice. There are many ways to effectively get rid of biofilms. Say get rid of. It's very difficult to break them down. Um, I've done quite a bit of research in this area. One of the ways is to utilize intravenous vitamin C.
Okay.
That's one way of breaking down methylene blue. Also, I think is capable of doing that. There are a number of natural compounds that are capable of doing that too. I think berberine is one.
Yeah.
So I don't have the full list in front of me, and I can't remember the exact ones. but they are mentioned in the book, and with other research that I'm now doing. I have a Substack so people can access that for free, where I put out different articles and different research that I'm doing. And yes, the in an ideal world, when you get a diagnosis, for me, you should try and find out what your fungal burden is within the body, as well as looking at the general cancer markers that there are. Find out what the fungal burden is in the body, the mycotoxins that you're exposed to, try and eliminate that. And if you can identify the fungal burden, say within a biopsy, I would be against biopsies because we don't want to spread any particular cancer cells in that process. But you can do things like an oats test to identify mitochondrial metabolites. That will give an idea of the burden within the body. But it's not an exact science at the moment.
Yeah.
I'm working with a number of scientists, and we're trying to establish a pilot study to test my theory. This is the ultimate goal. You know, people need answers. It's going to take time to do that. But what we're finding in this process is it's really quite difficult to find the perfect test that would identify all the pathogens we would want to identify. I mean, it's almost impossible at the moment. The technology just isn't there. But there are you treating physician should know of a number of different ways of identifying fungal signatures, such as the oats test is one. There are a number of others. They're not perfect, but it's a start. And if you get an idea of and if you do have a biopsy and you are able to do next generation DNA sequencing on them to identify DNA signatures of fungal pathogens, then you'll get much better idea of what pathogens are present. Because this is one of the things that Ravid Straussman did in Israel. He actually identified that he did DNA sequencing, and he identified bacterial and fungal pathogens being present in all tumors. So this is really the revelation, and it's only come out in like 2017. That was the fungal side of things. So we're only beginning to realize that actually tumors aren't sterile. So this again nicely highlights this that these are present in the tumors, and scientists it's pretty really new, and they don't know why yet, because up until that point it was thought that tumors were sterile. So it's kind of like come at the right time for my theory, really. So I'm explaining the exact mechanism of why and how they are able to, and his research is showing that actually they are present. So Mark's theory has a certain level of credence, because if there weren't pathogens present in all tumors, then my theory falls flat, doesn't it?
Yeah.
But there are. So yes. So it's testing for the pathogens. I mean, for instance, in pancreatic cancer, they found that Malassezia, I'm not sure if I'm saying that right, Malassezia or Malaysia, fungi were present. And when they used antifungal drugs, they reduced the pancreatic tumor by 40% and stopped it from growing. But then they reintroduced that pathogen. And it started growing again. And there's been a recent study in 2025 that was looking at Candida albicans, common fungal pathogen. A lot of people will know about that, with melanoma, and they introduced this pathogen externally to the tumor, and it upregulated all the pathways we see associated with cancer and made it more aggressive and progressed the disease. So that study alone was saying, well, clearly there's a cause and effect thing going on here. It's not necessarily that study doesn't necessarily prove my theory correct, because it wasn't talking about intracellular fungal pathogens, which is what I'm talking about, but it highlights that there's this link, and it suggests that we should be bare minimum considering antifungal therapies. It even mentions itraconazole in the study, and that's what I'm trying to say. Really, with my theory, is that I'm not saying that I'm right. I'm saying that all the evidence points down this one route, and that if you take anything, just one thing from my theory, is that if you start thinking about targeting cancer from a fungal perspective, an antifungal perspective, then there is great potential in improving your outcome, because you can use these therapies in synergy with what you're already using, especially metabolic therapies. So it gives you an additional weaponry, I suppose you could say. So that, yeah, that's really the benefit. So it's trying to find out the source of mycotoxins, eliminate that, trying to find out using certain tests what pathogens are present. And the reason why, sorry, I mentioned Malassezia, I went on a tangent there, is because they actually primarily consume fat. So you would want to consider, that's why you need to understand the different types of fungi that are present. You might want to consider a statin for that. I mean, I'm not a fan of statins, but they have been shown to block fat pathways. But and lovastatin, for instance, is antifungal as well. So you're hitting both the metabolic pathway and the pathogen. So yeah, that's super important. But really try and do it as holistic, as healthily as you can with natural antimicrobial compounds and a combination. And
Yeah.
the final thing I would say is a lot of people say, well, I might have tried an antifungal drug and it didn't really work. It's a lot more nuanced than that, in the sense that itraconazole, for instance, which is one of the most seems to be one of the most effective. Um, it it is a fungostatic drug. It's not a fungicidal drug, so it's not going to kill the fungus necessarily. It's going to inhibit the fungus, and what it requires is that the immune system then takes over. So it's helping the immune system. It's paralyzing the pathogen for a short period of time. Then the immune system needs to sweep in and deal with it. But the problem with cancer is that the immune system is switched to a Th2 or an M2 phenotype, which is the cell repair phenotype. So the immune cells coming in are going, right, what's going on here? Oh, we need to repair the cells, so let's repair things. And that's because the pathogen itself forces this switch to this secondary cell repair phenotype. The reason for that is so that the pathogen can hide from the immune system. What we want to do is want to shift it back to a Th1 or an M1 phenotype, which are immune cells that target intracellular pathogens. That's why the fungus does that. It doesn't want those immune cells coming into the cell to eliminate it. Very clever. So if you're going to take itraconazole or something, an antifungal, it's fungistatic, you want to modulate the immune system back to a Th1 response, which you can do with medical mushrooms, mistletoe, or then there's a number of other natural compounds as well that have been shown to trigger the immune response back to this Th1, where the immune cells are infiltrating and looking for intracellular pathogens. So there needs to be a combination of those two things to make it more effective.
Yeah, and it's interesting because I have interviewed a lot of alternative cancer researchers, Dr. Seafried. Gosh, I'm blanking on the other guy who talks a lot about mistletoe and but it's just like putting it all like you put it all together into one thing or into one resource. So well, thank you for all your research. So this is the book, The Cancer Resolution. Um, very, very resourceful. A lot of information in here.
And
Um,
it's written for cancer patients. So I wrote it for effectively my parents and my friends and family to understand it. So they didn't need me to explain things. So I've got
yes,
all the evidence in there, the quotes, and I then translate the evidence into layman's terms so that anyone can understand it. So
yes,
it's super helpful for patients as well as clinicians.
that's key. Yes, and the clinicians too. It's like they need to understand where you're coming from, and some, you can present some things, and but if they have a resource and they have studies, they can go and see that they're backed up. That's makes it a lot more credible for sure. So, well, we are so excited about the work that you've done, the cancer resolutions, your book. Is there anything? And I see Dr. Nasha Winters wrote your foreword. I'm a big fan of her work as well.
Yeah, she's fantastic.
Yes, she's done a lot of work in the field as well. Is there anything else that we didn't touch on that you just really want people to know? And I would think everything's in the book. But such a fantastic resource for people who just are feeling, just gives them hope. Like, and that's such a critical component.
Yeah, because
Get that diagnosis.
Yeah, because I think what my work does is effectively empowers cancer patients so they don't feel
Yeah,
helpless anymore. They're not just
exactly.
sitting there doing nothing and hoping for the best and hoping that the physician is looking after them as best he can. That you can be proactive now because you have information there that gives you a framework for, oh, this is potentially what's happening, or that's potentially what's happening. Those three theories say this, and they're the most accurate. And so how can I target those particular mechanisms? Oh, I'm getting results. So it's a to and fro effects, and it gives that hope. But also there are other fantastic resources out there. especially alternative resources. I've had a lot of help from a particular cancer charity, Yes to Life in the UK, and they do great things in educating patients, highlighting where you can gain access to functional medicine practitioners, alternative sources of information, and just general information, support groups, emotional support groups. And they're Yes to Life are brilliant at doing that in the UK. And there are many more charities out there as well as in America. So seek them out too, not just this information.
Awesome. Well, thanks again for putting this all together. Is there anywhere else that people can find you? So we definitely will point them toward the book. Anywhere else where you put information out? I know you have a website as well. We can link that in the show notes.
Yes, mainly the website. So the website is cellsuppression.com. So there's many links on there to different podcasts, resources, and there's also a free resource on there. I've got a synopsis of my theory explained over about seven or eight pages, and that just summarizes the theory in layman's terms. So that can be, you can provide that to your oncologist, and they'll understand where I'm coming from, rather than, giving them that big book, which they're not going to read. They haven't got time to read.
Right.
But the
Right.
synopsis, really short, A5 pages, about eight of them, uh, summarizes the key features of my theory and how it fits in with the others and how it can potentially help. So that will help spread the word and really explain the theory simply, easily, and quickly for anyone who's interested.
Yes, yes. Oncologists are very busy people. And like you said, they probably have a whole stack of
They do, yeah.
resources they're trying to get through. So, well, thank you again for your work and for coming on and for explaining everything to us, and giving people hope. Like we said, we really appreciate you coming on and spending an hour with us.
Thank you. It's an absolute pleasure. Absolute pleasure. So take care of yourself and I'll see you soon.
Thank you.